Hello, this video is a short tutorial on the UCR USV tool. This folder is the exact folder that I have provided in the email, except this WAV file, this audio file. This one is a short recording of mice vocalization that was recorded by the neuroscience department, and I'm going to provide a separate link so you can download this as the sample WAV file that we will be testing in this tutorial. But all the other files are in the UCR USV folder. In order to start running the tool, so here UCR USV tool is the application. It's an executable in MATLAB. So in order to run this, you need to download and install the MCR for MATLAB. So if you just open the browser and you type MATLAB MCR, the first link here, MATLAB compiler runtime, which stands for MCR, has the free MCRs here, so you can just download and install them. There are a couple versions here. You need because we have compiled the code with this version of MATLAB, so you should download this. So if you have the Windows operating system, depending on 32-bit or 64, you should just download one of them and install it on your computer. Right after you install this, you will be able to see this icon besides this file, which is the MATLAB icon. And so after you install the MCR, you just have to double click on this tool. So if I double click, you're gonna see a black screen opening up, and it takes a couple seconds to open the tool, which is built in MATLAB. So here we go. So we don't need this actually. I'm just gonna minimize it. You can't close this, you just have to minimize it. So this is the whole tool, and all of the files that we need in order to input to this tool are here in this folder. So I'm gonna go step by step through this tool. First of all, the tool is based on this recording, so the frequency of the recording, it's like dependent. I mean, the tool depends on the frequency of the recording and something like that. So if you try your own recordings using this tool, you may, I mean, it's possible that it doesn't extract any syllables, or it's not able to work on it, but we have to tune it. So I mean, our tool is based on these recordings that we got from the neuroscience department, so it's just working for these files right now. For a different species, or for a different quality of recording, we may have to tune some of our parameters. That's easy. If you just want to send me a sample of your recordings, I can easily figure out I can just tune up the tool. Okay, so here the first part of the tool is the extracting the syllables. So the first input here, if you click browse, it's going to you should select the WAV file, the recording. So if I browse this, I'm gonna go and pick actually this WAV file. I'm going to select that. So here inside this folder, I'm gonna select this audio file, or this WAV file. So the format should be .wav and nothing else. If it's like MP3 or something, you have to convert it to WAV. So I open this, and then here the next input is the destination folder. So it's going to be a folder which will contain all of the results that get produced by the tool. So I'm gonna go back here to this folder. You can create this folder anywhere, and let's just call it results. So all of the results are gonna be written in this folder. So we go back to the tool. Here I'm gonna browse and select this folder that I created. The next input here is the time, the starting time and the ending time of the WAV file that you want to process. So let's say start from second 100 to 103. So we're just going to process 3 seconds from 100 to 103. And the next setting is the gap threshold for combined calls. So you just have to, I mean, the default is 10 milliseconds, so you can, I mean, just leave it blank. And finally, you have to click extract. So if you click extract, it's going to extract the syllables for the mice from the audio file. So when you get finished, if you go back to the results folder, you're gonna see a folder with the same name of the wave file, which includes, so if you go inside this folder, you're gonna see the syllables which are extracted from second 100 to 103. If you look at every image or every of these syllables, it has a starting, the label of every image is the first number is the starting point, is the starting, I mean, point of this syllable. So this is like in milliseconds. So it's 100.561, and then this is the ending point. So it's 100.601. And then this is the minimum frequency, it's the minimum frequency and the maximum frequency of the, so this is like 37 kilohertz and this is 79 kilohertz for this syllable. So this is 37 here and then 79 here, and so on. So all of them are labeled like this. So if you go back here to results, and it includes 2 other folders which you can just ignore. You don't need to, I mean, use them. These ones actually include more. It may include more syllables, which also include noise, and then we remove the noise and create this folder. So this folder is all of the clean syllables without including noise, hopefully. So let's go back to the tool. Now here, the next feature is filter. So you can just say like, I want to view, I mean, this is not a very important feature, you can ignore this one too, but it's like, I want to just filter out the syllables which I think, you know, are noise, for example. I mean, here all of them are almost are good, but anyway, I'm just gonna yeah, so this option is just in order to view the extracted syllables, and then you can like take out the ones that you think are noise. The next button here is call rate. So if you click, it's going to show you the number of, so here we have the number of calls, the number of syllables, and every second. So we have a sliding window of 1 second. We slide it through the time from 100 to 103 seconds, and then in every 1 second we count the number of syllables. So here, like, we have at this time, at this data point, we have like 7 syllables and 1 second, right? So like half a second before and half a second after. If we count the number of syllables, it's going to be 7, and then it goes down, and then here we have like only 3 counted here. Then the next step is the basic operation. So if you click like on durations, it's going to give you the minimum duration of the syllables in milliseconds, the maximum duration, and the mean duration. And it's also creating inside the folder, inside the results folder, it's going to create a file called durations, which is a text file. It includes, if you open it, it will include all of the durations for the syllables from the beginning to the end. So it's in milliseconds actually. And then the next one is the frequency, so the minimum, the maximum, and the mean frequency. And then again here a file called frequencies.txt, which includes all of the frequencies. And then here other info, if you click, you're going to get the total number of syllables. We only have 10. We only extracted 10 syllables between 100 and 103 seconds. And then the average gap between every 2 consequent syllable is 134 milliseconds, and then the maximum gap is this much. And then here you're going to have another file called gaps, which includes all of the gaps between every 2, you know, consequent syllable. The next step is the classification section. So the first input for here is the dictionary. Again, the dictionary is created by the neuroscience guys. So what they did was actually they extracted syllables, like a lot of them, like let's say like for 10 minutes, okay, or even more, and then they just decided that how many classes we have in those syllables. So for example here, if I go back to this folder that we have provided in this in the UCR USV folder, it's called normalized ground truth. So if you go here, we have 108 items, and they're labeled by a number at the beginning. So from 1 to so from 1 to 11. So this means that we have 11 classes of syllables, and then um, again the rest of the labeling is the same. So this is like different instances of class 1, and then like this is different instances of class 2, and so on. So this is going to be the ground truth that was provided by the neuroscience people. So they tell us that we have 11 classes, and then they gave us a couple instances for each classes. So we're going to go through all of the syllables that we extracted here. Actually, so we're gonna go through all of the syllables that we extracted here, and we're gonna compare them one by one to the normalized ground truth, and decide that which one belongs to which class. So here I'm gonna browse this normalized ground truth, select folder, and then you can ignore this option. It's again the same thing as filter here. You can just view the elements in the dictionary, but forget about it. And then the next input is the thresholds. So again, thresholds is one of the full files that we have manually created based on this data set. So it's a set of thresholds that show that like for every class, what is the distance, what could the distance be for any element to the elements in that class. So I'm just gonna pick the thresholds, and then I'm gonna pick and then the last one is the list of the labels of the dictionary. So it's gonna just, so it just looks like, so the labels, it just looks like it's just giving me the classes, of the syllables in the ground truth. This is something that we have to create by our own. And so we go here, the label ground truth, and finally we click classify. So it takes some time to classify the data, to classify the extracted syllables. So after we get finished with the classification, if you go back to the results folder, you're gonna see 11 folders, and every folder includes the syllables that belong to that class. So if you go back to the tool here in the summary of results, it's gonna show us that okay, one of the syllables belongs to class 0, which means that it wasn't able to classify this item. But like 5 of the syllables belong to class 3. So if you go to class 3, you're going to see like 5 items here that belong to the same class. They're almost the same shape. And or like 2 of them belong to class 8. So if you go to class 8, we have 2 that are similar to each other. So this classification is based on the normalized ground truth that we had here, that was defined by the experts. And finally, if you click on class numbers, it's going to create a file in results, which is the list syllable classes. If you open this up, it's going to show actually the class number of every element in the order of time. So at this time, in milliseconds, it was first class 8, and then class 8, and then class 7, 3, 3, 11, 3, 3, 3. So we totally had like 10, actually we had 10 syllables that were extracted in the first part, right? And one of them was actually not classified, so that's why we only have 9 classified syllables here. And that's it. So we can make some improvements on this. For example, I mean, this label ground truth, I guess, I mean, this input here, the list of labels for a dictionary, it's something that I have to, I think, automatically create. Uh, but I mean, for now, you can just test it on your own data and see if you can get any results, or if you couldn't, if you can just send me a couple seconds of the recordings that you have, and I'll play with it and see if I can get any um, results, any syllables, any calls I can extract. Thank you very much, and have a nice time.